Hi. So now we are moving to build our small economy, and we're going to start with production structure. So first thing we need to decide about is how are the companies producing goods. And to make things simple, we will be using Cobb-Douglas production function. So look, number of manufacturers produced in the economy depends on capital used in the production of manufacturers taken to the power alpha m times labor in the production of manufacturers times 1 minus alpha m. Well, I hope at this moment you're already noticing that this production function implies constant returns to scale, and this is the function we actually dealt with many times with different economic problems, but we will go back to constant returns of scale a little bit later. Okay, and production of food is also given by Cobb-Douglas production function. We'll just index it with f instead of m. And of course, in both cases, we've got that alpha m and alpha f must be between 0 and 1. And look, for now, we need to derive a couple of properties of our production structures directly from the production function. So I will do it for manufacturers, and just remember that exactly the same thing can be done for food. We just need to change m for f. Now, I'm going to use here a couple of mathematical tools that you might be a little bit rusty with because we haven't discussed them in a while, I believe since dynamic economic analysis. So, in the description of the video, I'm giving you a link to explanation of differentials in general, explanation of total differential that we're going to use in just a couple minutes, and the Lagrange multiplier method and optimization under constraint. You can find this all in the description. If you don't remember how to use those things, just view the videos. You need to just know the basics. Come back and let me show you how this is gonna work. Okay, so first, let's consider a very simple problem. Let's just say that our entrepreneur that produces manufacturers, wants to produce given some given amount of manufacturers, right? Some constant number. Now, this number might be any number, but we want to keep everything here simple. So let's assume even more that our producer wants to just make 1 unit of manufacturers. Okay, now we clearly see that the production of manufacturers depends on capital and labor used in the production process. So, what combinations of capital and labor do we have at our disposal? Look, in order to find this out, we need to construct isoquants, something you should also remember from Introduction to Economic Analysis. How do we do it? We just differentiate this equation. Okay, let me start with this. and so m. Now, dm, if m is some, first, if m is not constant, then in general, we can write that this is partial derivative of m with respect to km times change in km plus partial derivative of m with respect to lm times dlm. So, look, what we see over here is that level of manufacturers can change depending on the change in either capital or in labor. But what if I want to keep the amount of manufacturing constant, or what if I want to just keep producing 1 unit? Of course, differential of a constant is 0, and then all we have to do is to calculate appropriate derivatives. So, out of this, I'm getting this is alpha m, right? I'm differentiating partially with respect to km. Km alpha m minus 1 times this expression, which stays the same, L m 1 minus alpha m. Right? Then we've got dkm plus partial derivative of this, which will start with 1 minus alpha m times k alpha m times L to the power negative alpha m, right? Because here we also subtract 1, right? Because we calculate the derivative. So we've just left with negative alpha m, and of course we multiply this by Lm. Okay, so now look, what I'm going to do is to move this part on the other hand side of the equation. So I'm going to have minus here and equality over here. And now look, what I want to do here is to divide both sides by dlm and divide both sides by this entire expression, right? So, if I'm going to do so, I'm going to get that this is, that I've got dkm dlm equals to, we've got 1 minus alpha m over, first maybe minus 1 minus alpha m over alpha m, right? What I did first is that I took this expression and I divided by this one. Now look, then I need to divide km. I can just do it in any order because it's multiplication, and divide it by this expression. So I've got that this is km to the power alpha m, all divided by k m to the power alpha m minus alpha. Okay, and here we are continuing. Then we've got lm to the power minus alpha m, and now we are dividing it by this expression, right? lm 1 minus alpha m. And of course, this is it. Now look, we can simplify this expression greatly with relative ease, because look, those two cancel each other out. So we get km to the power negative 1, or simply km. Here, negative alpha m cancel each other out, so we get 1 over ln. Right? So finally, I can write that derivative. I can write the derivative dkm dln is equal to negative 1 minus alpha alpha m over alpha m times k m over L m. Okay, what we've calculated here is a very special derivative. Look, what have we assumed? We've assumed that we've got first, we've assumed that we've got manufacturers being produced by using Cobb-Douglas production function. Now, we've established that if I want to produce just one unit, so I can change level of capital and labor accordingly to get the level to get this one unit of production. Look, this basically means that I can make this one unit using, for example, a lot of labor, just a little of capital, with a lot of capital, just a little of labor, or maybe some combination of the two. Now, what we are actually getting from this, in return here, we've got the slope of a line that we are gonna call isoquant. And isoquant basically is the set of all combinations of inputs needed to produce a given amount of something. And I hope you remember this because isoquant is also something from Introduction to Economic Analysis. Now, what we've got over here, we know that the slope of this isoquant is given over here. And the slope is called marginal rate of technical substitution. Okay, we clearly see that because this and this and this and this is positive, the slope must be negative. If we would calculate actually a second derivative, we would find that the second derivative actually is positive. Don't worry, we will get to it. Here we have capital used in manufacturers, labor used in manufacturers, and capital used in manufacturers. So, our isoquant will look like this. Okay, look, how do we read it? Basically, we can call this isoquant, for example, exactly the way we did m equal to 1. Look, here you have set of all the combinations of labor and capital for which you will get one, if you use them, you will get 1 unit of labor. So, if we are in point like point A, we see that we are producing effectively. Now, if we would use combination like, let's have this in here, right? Look, what do we get over here? Look, over here, we can see that if we have a point like B, we do not have enough either labor or capital to produce. We are below this line, so we can build like half of manufacturers, or 1/3. Now, we can also, so we see that every combination below is not enough to produce 1 unit. Now, every combination, on the other hand, that is somewhere above would be inefficient. Because look, if I have a point like C, I can, let's put it a little bit more. Look, at this point, look, I can make having this amount, I can produce 1 unit of manufacturers, for example, using this much less labor. I could decrease labor by this amount and I would still be able to produce 1 unit. So, in other words, those combinations over here are inefficient. So the entrepreneur definitely wants to be somewhere on this line. Okay, so now that we have established what is isoquant, we can use the isoquants to describe production within manufacturing and food sector. Okay, so look, let me just draw 2 different isoquants. Okay, maybe this one with a blue color. Okay, and look, those 2 isoquants are representing production of 2 different goods. I'm sorry for that. And look, we can clearly see that production of this good requires more capital. What do I mean by that? Look, in production of the process, we require either a lot of capital and little labor. But look, when we are getting more and more labor, you see that it's harder and harder to substitute for capital. And actually, we need to add a lot of additional labor in order to compensate for the capital that we are not going to use. So we can say that this isoquant is associated with some capital-intensive process. And how we can measure capital-intensive process? Where do we get this capital intensity? Well, from our production function. Look, our production function had a specification Km alpha m times Lm 1 minus alpha m. Look, I hope you can remember from everything we did with Cobb-Douglas production function, so this part, that actually those parameters are measuring factor intensity. The higher is the value of alpha n parameter, the higher is the value. The higher is the share of capital needed in order to produce this good. So look, we can say that in this case we have a case of manufacturing because this technology is capital intensive, right? Now, if we would consider the second group we've got in our economy, so food, we would see that probably production of food will be more labor intensive, and it would be represented by isoquant like this. And look, this isoquant, in case of this isoquant, is way easier to replace capital by labor. But now we see that if we want to compensate for labor, we would have to add more and more capital. And look, this is the additional assumption I've been telling you about. Now, this additional assumption says is that production of manufacturers is capital intensive while production of food is labor intensive. Okay, if we combine those two statements, we basically see that the additional assumption on the structure of production that we need for this economy is that alpha m is bigger than alpha m, which in simple words means that production of manufacturers is more capital intensive than production of labor. Okay, thank you for your attention. In the next video, we're going to deal with cost minimization.